going to continue with the MPTF modeling of the two lines, LOB1 and LOB3. So I'm going to open the database again. And we've already designed a composite triangle group, so perhaps a quick way of searching for it is you go to under database tree structure, type of TG. If you click on the plus sign, you go to composite, and you'll see that we've designed a triangle group which is called LOB1, LOB3 training. Open that, and now in the models tab we can see also some composite models. So under the models tab, what you see is it's an incremental composite data set, and there's the models button is active, the composite models button is active, composite models button is active. The related, if you click on related, you're looking at related models. Let's go back to composite, and why don't we let's run say optimal 2. And you remember with optimal 2 we had a lot of parameter constraints. So for instance, this parameter here, because it's set to be the same across LOB1 and LOB3, the correlation would actually be 1. So if you go to CO, the correlation button, it's good practice, with the downward arrow to come up with two menu options, parameter covariances correlations. If you click on iotas, it's 1. Okay. Now, so that's model optimal 2. Okay. Now, if we're going to do a forecast now, if I go back to my PowerPoint display, if you just forecast for one line of business, you forecast log normals in every cell and their correlations. We're going to forecast log normals in every cell and their correlations. But now that you've got process correlation and parameter correlation, there'll be also correlations between the cells, between the two triangles, between every two cells. These induce correlations between accident years here and accident years there, and they induce correlations between these calendar years and these corresponding calendar years, and they will induce correlations between the total reserve here and the total reserve there. Okay, so click on forecast. It's a familiar button. And now you've got a choice. Do you want to forecast for the sum of these two data sets, or only one of them? Well, actually, we want to do the aggregate distribution of LOB1 and LOB3. We don't want to bring in any forecasting scenarios. Let's suppose we just continue with the most recent trends. So click on OK. And now you've got a forecast table, and it says aggregate. So this is the aggregate. If you look at each line, LOB1, you're forecasting log normal distributions for each cell. LOB3, log normal distributions for each cell. But when you look at the aggregate tab, then these are not necessarily log normals because they are sums of log normals, and the only way we'll find out their distribution is by by actually doing the simulations from these correlated log normals, these ones, and they also correlate between the two data sets. Okay, there's a new button. Well, it's familiar to you because it's the same button in PTF FS. Let's open that, and it's also tabbed. It has a certain hierarchical structure. So let's click on aggregate. Okay, and what do we have for the aggregate? We've got on the aggregate tab, I'm going to maximize it again. On the aggregate tab, there's LOB comparisons. Let's look at LOB comparisons. This one here, LOB comparisons. Okay, we're on the aggregate tab, and we have a pie chart, which is not a great statistical display. Most statistical products will not give you a pie chart. This is just a reserve mean by LOBs, the percentage of the total reserve. So you can see LOB3 has got a higher reserve mean than LOB1. It's 62% of the aggregate, 37, almost 38% of the aggregate. This is the CV of the aggregate. Typically, the CV of the aggregate will be less than the CVs for most LOBs. Okay, the coefficient of variation of the aggregate distribution, the aggregate reserve distribution, will be less than most of the CVs. In this case, it's actually less than both CVs. If you point to the LOB1, you also get a caption about what the CV is. LOB3, you also get a caption on the CV, and then you also get captions when you point at the pie chart. Okay, we're still on aggregate. Why don't we go to accident years? Can you see there's at the same level? We could look at summary by data sets, the same level in the tabs. It's hierarchical. And now summary by data sets, let's check on accident years. So this is the accident year reserve mean and ultimates that you also have in PTF. We then have calendar years. You have observed mean versus estimate. You've got some loss ratios. You've got incurred losses. That's all at the same level. Let's go back to summary by data sets. If you go further down, you've got risk capital allocation, which is based on a variance covariance formula that you will find in the manual. So if you go to help, go to manual. Let's click here so we get I think I remember, instead of doing a search, actually what happens if you do a search for risk capital just for fun? It might take me there instead, or there it is. Okay. Oh, there it is. So oops, just lost it. I went too far. It's page 97, I think. Risk capital. Oh, there it is. Okay. So the risk capital, the proportion of risk, once you decide on the total risk capital for the two lines of business, which will be based on VaRs and T-VaRs, the proportion of capital you assign to a particular line, it's the variance plus the sum of the covariances of that line with the other lines divided by the variance of the sum. If the lines are in fact independent, there's no correlation between the lines, it's the variance of the line divided by the sum of the variances. It's called a variance covariance allocation formula. Okay, let's go back into the system. I can close the manual. We've also got correlations. That's the correlation in reserve distributions, and that's the correlations here on a log scale, which I guess is more linear. Let's go back to summary by data sets. So with that level, let's look at accident years, or let's know risk capital allocation. Okay, so let's look at the tabs: aggregate, accident years, risk capital allocation, but I just want the summary. It's a summary. And as you go to LOB1, you get the summary by accident years, LOB3 summary by accident years. Go back to the aggregate. You can go back to risk capital allocation, and that's risk capital allocation by accident years, but you can also look at by calendar years. Okay, you can even look at the correlations if you wanted to between. Any of these tables, any numbers in these tables can be seamlessly extracted using COM and sent to any other COM-enabled product. Okay. Let's look back at summary by data sets, calendar years, summary. I'm going a bit faster, but anyway, you can play around, you'll work it out. And we've got a summary for LOB1, LOB3. Now we want to know the aggregate distribution. By calendar years, you also have the cumulative payment, mean payment, as a percentage of the total. So for instance, by about 2005, only 2 years going forward for LOB3, you've already paid 52% of your payments, whereas LOB1, it's about the same, 51%. Did we look at the reserve distribution correlation? I can't remember. So let's go to the aggregate summary correlations. I don't need that. Summary correlations. That's correlations by calendar year. So we want summary data sets. So it's 0.02. It's very high. Let's now, if you go back to the forecasting table F, we're going to simulate from these log normals for LOB1, these log normals LOB3 to find the distribution of the aggregate by accident year and calendar year. So go to PALD, reserve, OK, 10,000 simulations from each triangle. Let's do that. And you've got accident year total. You've got your density comparisons. It's the same as PTF. You've got your quantiles, value at risk. Quantiles are like percentiles, value at risk, and T. But there is a new table now, which is not in PTF, but it is in MPTF, risk capital. Click on that. So, assuming these quantiles, that's the risk capital. For instance, at 75%, your risk capital using VaR is 145 million, and you'd assign 54.7 million to line of business 1 and 90.6 million to line of business 3. It's better to look at these graphs. They're a bit more informative, risk capital graphs. This tab here. And I'm not sure that if you've set your VaRs and T-VaRs to be as much, I've got 75%, 90, 95, 99, 90.5. You can always go to the options button here at the top, and you can go to, I think it's called simulation preferences, and then you can go to set percentages, and you can set up your own default percentages. So let's cancel that. So just to revise that, you go to the options. It's an option at the top. It's not a button. You select simulation preferences, set percentages, and you can set percentages. So let's look at what's going on here. Let's look at that. Let's suppose we'll look at 95% of VaR. The total risk capital is 402 million. And this is how much you assign to LOB1. You can point to it, 151.5 million, and to LOB3. Where do we get those percentages? If you tile vertically, minimizing other types, so you only have this particular table displayed, and then you click on Forecast Summary, and on Forecast Summary you go to Risk Capital Allocation. So it's Aggregate, Summary by Data Sets, Risk Capital Allocation, and tile vertically. Well, if the total risk capital is 402.641 million, according to the risk capital allocation formula, so based on variances called variances, 62% goes to LOB3, and the 62% is 251. I mean, you can look at the 99th percentile. You can look at 99.5. Obviously, you need more capital, 99.5. You can change it to T-VaR also. So this is pretty interactive. If you wanted to add another percentage, with the right button of your mouse in the window, set percentages, and just for this run, you can add another percentage. And let's suppose we make it 99.95. Gee, you need a lot of money for that, wouldn't you? And click on OK, and you'll see it'll come up here, 99.95, go to VaR, and you can select. But if you get out of the system and come in again, in fact, I think even if you go out of this composite triangle group, you'll go back to the default, which is 75, 90, 95. Okay, let's maximize the risk capital table, interactive table. What other displays do we have? We've got risk capital as a percentage of the mean. For the aggregate, the risk capital in this particular case, when we're looking at VaR at 99.5, is 37%. LOB 3, it's 38%. LOB 1, it's 36%. It's another table. What do we have here? We have the risk capital, which is in blue, and the gray is the mean. So if you point to one of these boxes, I've pointed to LOB1. This is at 99.5%. That's why I said it. It tells me that the mean is 697.593 million, and the risk capital that I should allocate to LOB1 is 255. Then when you go to the fourth graph, bottom right, it's the risk capital as a percentage of the total by LOB. So the total risk capital for a particular line is the mean. The total capital, I should say, is the mean plus the risk capital. That's 100%. For LOB1, 26.83% is the risk capital, and the mean is 73.17% of the total. Okay. Now, why don't we now load a model in a new window? So load model in new window. So we want another run in MPTF. And now go to related and choose good 1 and good 3. So we're going to run good 1 and good 3 again. So it's not composite. We want to go back to our related models. In other words, our PTF models. Good 1 and good 3. Load. Then let's get rid of this parameter, because that's what we did in our optimal 2 models. So click on OI. Make sure LRB1 is active. OI. Now go to OC. Well, we're going to set the correlations to 0. Set all correlations to 0. And if you like, kind of save it as if you like, optimal 3, correlation 0. So let's do that, optimal 3, correlation 0. Then do a forecast. Okay. Then go to PILD. Okay. Of course, the means are going to be slightly different. Now, tile vertically, minimize other types. And I'm going to tile vertically again. Go to risk capital graphs. Okay, let's choose 95% VaR on each side. In fact, you can see that when we ran another model in a new window, the percentages are the default percentages that I've set up in my options. It doesn't include the 19.95 that we have there. Let's click on risk capital as a percentage of the mean by LOB. Which graph is that? That's that one. So at 95%, it's quite interesting. We're getting a completely different picture. At 95%, if the lines were assumed to be independent, there's no correlation. The percentage of risk capital above the mean you need for the aggregate is 18.44%. This is a VaR at 95%. So each one is a VaR at 95%. So on the left side, at least on my left side, you need 18.45% of the mean as risk capital. But on the other side, where you've got the correlations, you need a little bit more capital because of the correlations, because you've got less risk diversification credit. Okay? So, yeah, you know, correlations do play a very important role in the assessment of risk capital. So it's not just the correlation. Correlations do play an important role, but of course another thing that plays an important role is just the volatility in that particular line. So this is just an example that if you've got two pieces of business and the correlation is 0, and that's the case with most pieces of business, then you get a lot of credit for risk diversification. But if the correlation is, in this case, the reserve distribution correlation is about 0.8, you need much more capital. Okay. Now, of course, if you go to the X and close all MPTF modules, you're back to, well, I guess the triangle group standard below. You can go back to the triangle group, LOB1, LOB3, and just for fun, you can run both models, optimal 2 and optimal 3. Actually, we should have called it optimal 2 correlation 0, but it doesn't matter. You run both, so highlight both, open, just to show how fast you can do things. With the right button of your mouse on the forecast dialog, select all. OK. OK. With the right button of your mouse on the PILD button, so you get a shortcut context. When you get this kind of options, you want to run it for all. It's not a context-sensitive menu. OK. OK. Now tile vertically, minimize other types. On each one, go to the risk capital graphs. The other one, the risk capital graphs. You go to, say, 95% VaR. Click on risk capital as a percentage of mean by LOB for VaR 95%. Same on the other side. And you can do your comparison pretty quickly. Okay, it's going to get more exciting as we go on when we look at multiple lines of business. Close all triangle groups. Get back to the database, and this is the end of this video. Of course, you can continue and sort of play around and experiment.